Today we're doing the third set of notes and we are solving equations. So notice the premise of these is that you have to have the same base. If you have the same base, then you can set your exponents equal. So in letter A, you notice we have a base of 3 on both sides, so therefore x must be equal to the 4. So I know that problem was very easy and very basic, but the goal is we're going to start with easy ones and work our way up. Letter B, again, I have a base of 7 on both sides, so that means that this exponent gets set equal to the 9. So really, 7 has nothing to do with the problem. It gets dropped, and I say 3x equals 9. Divide both sides by 3, x equals 3. For letter C, again, notice I have a base of 4 on both sides. Set my exponents equal. So this 2x here has to equal the 2x plus 5. To solve for x, I need to get all my x's on one side, so I'd subtract the x's over, and x equals 5. Letter D, again, same base on both sides. On the right-hand side, notice there's no exponent, but since there's nothing written there, it's implied to be a 1. So 2x equals 1. Divide both sides by 2, so x equals a half. Again, as long as you have the same base, you can set your exponents equal. So now we're going to get into the little bit more difficult ones where we bring back the exponent rules. So when we are multiplying with the same base, that means I can add my exponents. So notice I'm going to write 1, 5 raised to the x plus 3x equals 5 to the third. And now that I have the same base, I can set my exponents equal. So x plus 3x equals 3. X plus 3x would be 4x. Divide both sides by 4. X equals 3/4. Letter F is slightly different than E. E we were multiplying, so I added my exponents. Letter F, I'm dividing my bases, so that means I subtract my exponents. So this is 2 to the 2x minus 3 power equals 2 to the 5th power. So I set my 2x minus 3 equal to the 5. I add 3. 2x equals 8, so therefore x must be equal to 4. So that is basic problems. So now we're going to get into practice rewriting bases if we need it. So down next to example 2, somewhere on the paper you need to write down imperfect squares and perfect cubes. So I would put the squares to the left of A and D and put your cubes to the right of C and F. So my perfect squares are 1, are 4, 9, 16, 25, and so on. We could keep that list going. Cubes, 1 cubed is 1. The next cubed is 8. Then we get 27, 64, and 5 cubed is 125. Again, you could keep going with this list. It's not something you need to memorize. You could always create it. So when we're doing this set of examples, you're going to reference back to this list to help you rewrite your bases. So letter A, I have a base of 4, and the goal is to make your base be as small as possible. So this base of 4 needs to be rewritten, and I can rewrite 4 as 2 to the 2nd power. But notice, this 4 here got replaced with a 2 squared. The other 2 came from before. Now when I'm doing a power raised to a power, I multiply my exponents, so this is 2 to the 4th. So again, 9, I'm going to rewrite it like this so you can kind of see my base is 9, exponent is x. 9 can be 3 to the 2nd power raised to the x. Multiply your exponents, final answer is 3 to the 2x. Letter C, we're going to start with replacing that 4 as 2 squared. And we talked about it in the first section when we did graphing. If I want to bring this 2 squared up and make the not be in the bottom of a fraction, I change it and it becomes a negative exponent. And now that I have a power raised to a power, it'd be 2 to the negative 4x. So I would like you to pause the video right now and you're going to try letter D, E, and F in example 2. and then we'll go over those answers tomorrow. Once you're done with D, E, and F, resume the video, and we're going to do example 3 on the next page. So example 3, notice we don't have the same base on both sides, so I have a 3 and I have a 27. So using the skills that we just practiced, I know that I can rewrite 27 as 3 cubed. And now I have the same bases, so my exponent is x equals 3. The 3 is coming from this right here, so x equals 3. Letter B, I have a 7 and a 49. The 49 is what needs to be rewritten. So I could say this is 1 over 7 squared. And if I want to move the 7 squared up from the bottom of the fraction, it becomes 7 to the negative second power. And now that I have the same base of 7 on both sides, I can set my exponents equal. So 2x equals negative 2, divide by 2, so x equals negative 1. So the goal is you got to get the same bases, then you can set the exponents equal. Letter C, anything to the 0 power is 1. So something you should jot down next to letter C. 1 to the 0 is 1, 2 to the 0 is 1, 3 to the 0 is 1, and so on. So in this problem, letter C, I have a base of 2, so I would like to rewrite this 1 as 2 to the 0 power. Now that I have the same bases, I can say 3x equals 0, divide by 3, x has to equal 0. Again, anything raised to the 0 power is 1. We rewrote it as 2 to the 0 because I needed a base of 2. Letter D, E, and F are getting into problems where we have to rewrite both sides. Notice A, B, and C, we only wrote one side. Now we're rewriting both. So this is 1 over 5 squared raised to the 2x. 125 is the same thing as saying 5 cubed. Now I need to bring this 5 squared up from the bottom, so I can rewrite this as 5 to the negative second power raised to the 2x equals 5 cubed. Multiply my exponents, I get 5 to the negative 4x equals 5 to the third. Now I have same bases, I can set my exponents equal. So negative 4x equals 3. Divide by negative 4, and x equals negative 3/4. So that was an example where we had to rewrite both sides to try and get that same base. So 2 more problems to do. Letter E, notice my base is 4 in this problem, so I would like to get rid of the 2 first. So if I need to get rid of the 2, we're going to divide both sides by that 2. So now I'm at 4 to the x equals 8. And again, we need to rewrite both sides. So 4 can be replaced with 2 squared. 8 is 2 cubed. So 2x has to be equal to 3. Divide by 2. So x has to be 3/2. So again, we got that 2 out of there from the beginning because my base is 4, and that's the only thing I'm concerned about. So I got rid of the 2, then I got same bases. Letter F, we have a 25, 125, and a 5. So the common base here will be 5. So 25 is 5 squared. 125 is 5 cubed. And this is 5 to the first power. So let's clean this up a little bit. We have 5 to the 6x, power raised to a power you multiply, over 5 to the 3x. And now you subtract your exponents. So this is really 5 to the 6x minus 3x equals 5 to the first power. I'm going to flip screen so I have more room. So you're at 5 to the 6x minus 3x equals 5 to the first. So 6x minus 3x equals 1. 3x equals 1. Divide by 3. X is 1/3. So that's all for today. Again, I would like you to try the next set of practice problems 1 through 6. All right, that's all.